Day number 7, playing a game called Camel Cards, which is similar to poker, not exactly the same. We get the same kinds of cards. We have 2, 3, 4, 5, and so on, up to Ace, Ace being the most valuable card to the least valuable. And the difference in poker is these cards don't have any suits, or if they do, they don't matter. So we don't have to worry about hearts or clubs or diamonds, whatever. And the game is played with hands of 5, so we get 5 cards that make up one hand, and these hands need to be evaluated according to their relative strength, and this is the hierarchy for the hands. So a 5 of the kind, which also doesn't exist in real poker, is the best kind of hand there is, and then 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, high card. So notice there's no straight, there's no flush, no royal flush. So it's a bit different than poker. Oh, and another thing that's very important, if we have two matching hands, so for example, we have a 3 of a kind, we have a 3 of a kind where one hand has 3 twos, and a 3 of a kind where one hand has three threes. In real poker, we would say the hand with the 3 threes is better than the hand with the 3 twos. But here it depends, because here we're looking at the hands chronologically from left to right, and the first card that is higher in the one hand than in the other hand, that hand is the stronger hand. I hope I explained that right. But yeah, so that's something very different in poker, because in poker there doesn't exist any order to the hand. There's no left to right in real poker. Here's the puzzle input. We get the hand on the left and its corresponding bid on the right. So here we have a 3, a 2, a 10, a 3, and a king. And if we've ranked all these 5 cards, then we assign a rank of 1 to the least valuable hand and a rank of 5 to the most valuable. We then multiply each rank to its corresponding bid and add up all these numbers, and that's our puzzle answer. So let's think about how we're going to do this. We need 2 things. First thing we need a function which can tell the type of a hand. So if we pass these 5 letters to it, it should say, oh, that's a 3 of a kind. Or here it should say, oh, that's a 2 of a kind. Sorry, that's a 2 pair. And so on. Once we have that, we can build a custom sorting function. That's the other thing we need. And if we want to build a custom sorting function, if you're not already familiar with the compare to key function by the functools library, this is extremely useful here. I put a link in the description for a Geeks for Geeks article, which is it goes into how this function works, but I'll explain it real quickly. So we can basically build a function which has the following structure. It has 2 arguments, a left element and a right element. In our case, this would be two different hands. And if the one hand, for example, was a 3 of a kind, and the other hand would be a 2 of a kind, then it should return 1. If however, the right element is a 3 of a kind and the left element is a 2 of a kind, then it should return -1. If they're completely identical in every respect, it should return 0. So if we build this custom sorting function and we pass it to the compare to key function by the functools method, and we pass that to the key parameter of the sorted function, then we just get our answer really easily. So let's see how we do this in Python. Let's start out by building a function which will return the type of a hand. So for this, we're going to import the counter from the collections module, which is a really easy way of counting how many instances there are of each character in a string. And we're going to see this in action real quick. We're going to take the second of the hands, the T55J5, and we're going to print what the counter tells us. So it tells us there are 3 5s, 1 T, and 1 J in it. That's perfect. Now we don't really care about the symbols themselves, just the values. So 1, 3, 1. And we want to order them, but in reverse, so the biggest one is up front. Now the biggest one will be the determining factor for determining which type it is. If it's a 5, then we have a 5 of a kind. If it's a 4, we have a 4 of a kind, and so on. If it's a 2, we have two cases. It could either be a 2 of a kind or a 2 pair, so we need to check that. Now we specify the return values. It's actually not important what we return. It's only important that a 5 of a kind returns a higher number than a 4 of a kind, for example. But it does kind of make sense to just say 5 of a kind returns a 5, 4 of a kind returns a 4, and so on, just for simplicity's sake. And let's check this out if it works. So this hand should return a 3 of a kind, and it returns a 3. Perfect. Works. Next up, we're going to build our comparison function, which takes in two arguments, a left element and a right element, which in our case will be two hands, and we're going to get the type of each hand. Is it a 3 of a kind, a 4 of a kind? What is it? And then if the type of the first hand is greater than the type of the second hand, we're going to return 1. If it's the other way around, we'll return -1. And if it's neither, we'll return a 0. Let's check if our function works by taking two different hands and comparing them with one another. First we take a 3 of a kind, and then we take a 2 pair. The 3 of a kind is more valuable than 2 pair, so it should return a 1, because the more valuable one is on the left. Now if we reverse the order, it should return a -1. And it does. Now if we take two hands with an equal type, for example we take two hands, both are 3 of a kind, it returns a 0, because they're both equally as valuable. But remember, this is not quite what we want. We want the one on the left to be more valuable, because if two hands have the same type, then we go through each hand chronologically from left to right and find an index at which the two hands differ, and then we return the one with the higher valued card. So let's create a dictionary with the card values, and then we iterate the indices of both hands and compare the card value at each index. If we've checked every index and we haven't found any difference between the two hands, then theoretically we should return a 0, but this should not happen. If this happens, there's something wrong with the puzzle input, because we have duplicate hands. Alright, we have all the pieces now, we just have to put them together. We import the regular expressions module, and we import the compare_to_key function from the functools module. Now we're going to create a regular expression pattern, which is 5 word characters followed by a space, followed by a number, collection of digits. We see if this works. We use find all, and this should give us all the hands and the bids, and it works. We get tuples containing the hands and the bids. We store this in hands, and then we're going to sort this list of hands according to our function. So we take our custom comparing function and pass it to the compare_to_key function as the key parameter of the sorting method. And I see there's a mistake. Right, now we're dealing with tuples now, so we have to unpack the tuples. So we index at 0 to get the hand from the tuple. Now it should work, and it does. First one's a pair, second one is a 2 pair, third one is also a 2 pair but a more valuable one due to the king, and the last two are 3 pairs, with the one with the queen being more valuable. Now we can use the enumerate function to retrieve the rank, because the rank is now basically the index of the hand. The first hand will be of index 0, but we have to start at counting at 1, because the lowest hand should have a rank of 1, not 0. Now we add the rank times the bid to the total, and we return the total, and we get our answer. And I just realized I made a mistake. I didn't account for full house, which is a 3 of a kind plus a 2 of a kind. So I'm just going to insert another if clause into the getType function and return 3.5, some number between 3 and 4. And it works. Cool, that's it for part 1. Part 2 is very similar to part 1. We just have to change two small things. First is the J, which used to be Jack, is now the Joker, and it can be swapped in for any other card that's present. For example, if we have 3 kings or 4 kings and we have another J, then we can turn the 4 kings into 5 kings, or the 3 kings into 4 kings. So the J acts as a wild card. The second thing we have to change is if we encounter the J on its own, it's now the least valuable card. So it's less valuable than a 2. Okay, let's jump to the code. So now when we analyze the type of our hand, we have to first extract all the jokers from the hand. We store the number in a variable called jokers, and we add that number to the count of the most frequent card that we have. And now we switch the value of the joker from 11 to -11, and we're done. And it's not working because apparently we can get hands of 5 jokers, so the hand is empty afterwards. So let's take care of that edge case. If there are no counts, then we'll have a count of 0. This takes care of it, and we got our answer. Thank you for watching. That was part 2. If you're also a big fan of Advent of Code and it's helping you to learn to program as it helped me, you might also enjoy visiting my website where I keep all the solutions I've got so far, presented in an interactive and hopefully appealing way, as well as other fun stuff. See you there.